What if the undisputed king of the skies, the F-35, faced a challenger that could truly shake its throne? For decades, the F-35 has reigned supreme, a marvel of engineering synonymous with aerial power and technological dominance. It's not merely a jet, it's a statement, a testament to American ingenuity and military might, setting the benchmark for what a modern fighter aircraft should be. But now, a new shadow is emerging from the east, a stealth fighter that whispers promises of an altered future, one where the balance of power might dramatically shift. Could this new contender from China truly threaten the established order of air superiority, forcing the world's leading air forces to reconsider their strategies and capabilities? The implications could be profound, reshaping alliances and redefining what it means to control the skies. The dawn of the 21st century marked a pivotal moment in the history of aerial warfare, ushering in the era of fifth-generation fighter jets. These weren't just faster or more agile aircraft, they were revolutionary platforms defined by their groundbreaking stealth capabilities. Iconic examples immediately come to mind: the F-22 Raptor and F-35 Lightning II from the United States, alongside Russia's formidable Su-57. These jets didn't just join the ranks, they redefined them, establishing new standards for survivability, combat effectiveness, and technological integration. Their advent created immense pressure on other nations to innovate rapidly, to catch up, or risk being left behind in the evolving landscape of global defense. For China, this challenge was particularly acute, spurring an intense, clandestine effort to develop its own stealth platform. Beijing recognized that to truly compete on the global stage, it needed a fighter that could go head-to-head with these titans. After years of relentless research and development, often shrouded in secrecy, China finally unveiled the J-20 in 2017. Known as the Mighty Dragon, its introduction was a significant geopolitical statement and a major leap forward in China's aerospace ambitions. Yet as groundbreaking as the J-20 was, it appears to have been merely a prelude, a stepping stone to something even more advanced, more disruptive. What secret weapon has China been perfecting in the shadows, and how might it alter the very fabric of future air combat? The answer, it seems, has now taken flight. Despite the J-20's impressive capabilities and its symbolic importance, it wasn't the final answer for China's ambitious aerospace goals. The nation's drive for technological autonomy and military parity continued unabated. Just recently, the world witnessed a new chapter unfold at the 15th Zhuhai Air Show, held from November 12th to 17th, 2024. Amidst much anticipation and speculative murmurs, a new stealth fighter, designated the J-35, made its public debut, taking to the skies for its maiden flight. This wasn't a sudden, overnight sensation. Rather, it was the culmination of a deeply ingrained, long-term strategic vision. Its genesis traces back to the mid-2000s, with development commencing under the meticulous guidance of two of China's most prominent defense entities, the Aviation Industry Corporation of China, AVIC, and the Shenyang Aircraft Corporation, SAC. The journey from concept to flight-ready prototype was anything but swift or straightforward. It was a long, arduous process, filled with countless developmental hurdles and rigorous tests designed to push the boundaries of aerospace engineering. But what exactly did it take, behind the scenes, to bring this stealth dragon from the drawing board to the reality of its first majestic flight? And what kind of challenges did its creators overcome? From the initial conceptual sketches and detailed blueprints, the J-35 embarked on an exhaustive regimen of ground and flight testing. Engineers and test pilots subjected the aircraft to an unforgiving gauntlet of trials, scrutinizing every minute detail of its performance. They pushed the jet to its absolute limits, meticulously evaluating its raw flight performance, its intricate maneuverability across various flight envelopes, the efficacy of its low observable stealth features against sophisticated detection systems, and the crucial functionality of its advanced electronic warfare capabilities. Each successful test, each data point gathered, represented a critical step closer to realizing China's overarching strategic goals of achieving aerial dominance and technological independence. A particularly critical milestone, one that resonated deeply within military circles, emerged when the J-35 successfully demonstrated its inherent ability to operate effectively from an aircraft carrier. This single achievement was not merely a technical triumph, it unlocked an entirely new realm of operational possibilities for the People's Liberation Army Navy plan. It hinted at a dramatic, exponential enhancement for the Chinese Navy's power projection capabilities, signaling a transformative shift in their maritime strategy. Could this singular accomplishment truly herald a new era of naval air power for China, fundamentally altering the balance of forces in critical maritime theaters like the South China Sea and beyond? The strategic implications are vast and far-reaching, extending far beyond the immediate tactical advantages. According to prominent Chinese military experts whose statements were widely broadcast on state television like CCTV, the J-35 is not merely a prototype. It is envisioned for rapid, mass production and subsequent seamless integration into China's burgeoning fleet of aircraft carriers in the near future. This projected move is poised to significantly amplify the combined strength and operational synergy of both the Chinese Air Force, PLAF, and the Chinese Navy, PLAN. Should this vision materialize with both the advanced J-20 and the versatile J-35 in its operational arsenal, China would ascend to the remarkable position of being only the second nation in the world, after the United States, with its F-22 and F-35, to simultaneously field two distinct, operational fifth-generation stealth fighters. This dual capability would cement its status as a premier aerospace power. But beyond the geopolitical fanfare, what truly incredible features and technological marvels make this new jet such a formidable contender on the global stage? And how might its capabilities challenge the most advanced aircraft currently in service? The answer lies in its meticulous design and cutting-edge systems. China didn't just announce the J-35, they showcased an array of truly impressive technical specifications, signaling a direct challenge to established aerospace powers. This fighter is designed with an exceptional operational ceiling, capable of reaching a maximum altitude of 20,000 meters, which translates to over 65,000 feet. This isn't merely an impressive number, it confers a profound tactical advantage. Operating at such extreme altitudes allows the aircraft to engage effectively in high-altitude combat scenarios, leveraging the thinner air for superior maneuverability and fuel efficiency. Crucially, it also enables the J-35 to evade numerous threats from conventional ground-based air defense systems, which often struggle to target aircraft operating at the very edge of the atmosphere. This superior altitude capability fundamentally dictates the terms of engagement, allowing the J-35 to choose when and where to fight, providing it with a critical advantage in survivability and mission effectiveness. How does such an altitude capability fundamentally change the dynamics of aerial warfare, shifting the advantage away from traditional surface-to-air threats? The J-35 is not just an elevated platform, it's a speed demon propelled by two powerful turbofan engines that enable it to achieve blistering supersonic speeds. Its reported top speed clocks in at an astounding Mach 2, which is approximately 2,470 kilometers per hour. This blistering pace is not merely a statistic for bragging rights, it's a vital component of its combat doctrine. Such speed allows the aircraft to rapidly approach and engage targets, conduct its mission, and then swiftly disengage from dangerous areas, minimizing its exposure to enemy fire. This agility and rapid response capability are critical for achieving surprise attacks and escaping pursuit. The ability to dictate the tempo of a fight, to strike swiftly and disappear, is a defining characteristic of modern air superiority. But how does speed alone, without sophisticated sensors and weapons, transform a fighter into a true hunter capable of dominating the modern battlefield? Crucially, as a quintessential fifth-generation fighter, the J-35's stealth capabilities are not just an add-on, they are paramount to its core design and operational philosophy. Being developed subsequently to the J-20, it naturally incorporates Beijing's most advanced and meticulously refined stealth technologies. This suggests an iterative improvement, building upon lessons learned from previous projects. Western military experts have meticulously analyzed publicly available imagery and design specifications, noting striking similarities in its overall shape, and specific design elements to the F-35, particularly in its frontal aspect and wing-body blending. These observations suggest that China has drawn significant inspiration, if not directly borrowed design principles, from its American counterpart. This convergence of design philosophies raises intriguing and often contentious questions about industrial espionage, reverse engineering, and the global flow of critical defense technologies. Is this imitation truly the sincerest form of flattery in the cutthroat world of military aviation, or is it a strategic necessity born out of a desire to rapidly bridge a technological gap? The answer has profound implications for international intellectual property and military transparency. Delving deeper into its stealth characteristics, one of the most noticeable design elements of the J-35 is its highly integrated blended wing-body configuration. This is combined with two distinct ventral air intakes positioned below the fuselage, a design choice strikingly reminiscent of the F-35. The J-35's twin-engine setup and its use of twin vertical stabilizers angled outwards further contribute to its low observable profile. The entire external form of the J-35 is meticulously optimized to minimize its radar cross-section, RCS, making it incredibly difficult to detect by even the most sophisticated enemy radar systems. This isn't just about crafting an aesthetically pleasing aircraft, it's about crafting an aircraft that virtually disappears from radar screens. Its advanced aerodynamic profile is characterized by numerous flat surfaces and carefully articulated angular edges, a design philosophy that mirrors the F-35. Furthermore, its entire surface is coated with advanced radar-absorbent materials, RAM, which further diminish radar returns, turning incoming radar waves into heat rather than reflecting them back to the source. This comprehensive approach to stealth is about making a jet a phantom in the sky. How does every meticulously crafted curve and precisely angled surface contribute to making a technologically advanced ghost in the battle space? Beyond radar stealth, the J-35 addresses another critical aspect of low observability, its thermal signature. The aircraft's engine exhaust nozzles, while featuring a more conventional veau-full shape, are ingeniously designed to be significantly more enclosed than previous generations. This design choice aims to drastically reduce the thermal plume emitted by the engines, thereby minimizing its detectability by infrared search and track (IRST) systems. These IRST systems are passive sensors that can detect heat signatures without emitting any radiation, making them particularly dangerous to stealth aircraft that are optimized against radar. This dual-pronged approach to stealth, encompassing both radar and infrared signatures, is absolutely critical for the J-35's survivability and operational effectiveness in modern, multispectral combat environments. Another defining feature that enhances its low observability is its internal weapons bay. Unlike older generation fighters that carry weapons externally, creating numerous radar-reflective surfaces, the J-35's ordnance is concealed within its fuselage. This, combined with a seamlessly integrated bubble-like canopy designed to minimize reflections, further reduces its overall radar cross-section. What kind of hidden firepower does this meticulously crafted, stealthy design conceal within its streamlined form, poised to be unleashed against its adversaries? Speaking of weapons, the J-35 boasts a remarkably versatile arsenal, indicative of its multi-role aspirations. It is capable of carrying a diverse array of armaments, including various air-to-air missiles for engagements in the sky, long-range cruise missiles for precision ground strikes, and an assortment of guided bombs. Its impressive internal payload capacity can reportedly reach up to 8,000 kg, allowing it to carry substantial firepower without compromising its stealth profile. A standout among these formidable weapons is the long-range air-to-air missile, the PL-15, developed with significant expertise by the China Academy of Launch Vehicle Technology. This missile is not merely a piece of ordnance, it is a critical component of China's strategy to extend its air combat reach and challenge established norms. With an approximate length of 4 meters and a diameter of 20.3 centimeters, it represents a compact yet potent package. How does a single, advanced missile like the PL-15 fundamentally redefine the rules of aerial engagement, pushing the boundaries of beyond visual range combat? Equipped with a highly advanced active electronically scanned array (AESA) radar, the PL-15 boasts a remarkable operational range of up to 200 kilometers. This incredible reach allows it to intercept targets with extreme precision, even at blistering speeds of Mach 4. This capability fundamentally alters the tactical calculus of air combat. It allows the J-35 to engage and neutralize targets from a much safer, standoff distance, significantly reducing the risk of counterattack from enemy aircraft. The PL-15 is also specifically optimized to inflict maximum damage on a wide spectrum of aerial targets, ranging from agile fighter jets to slower but equally critical cruise missiles. This is achieved through its potent fragmentation warhead. When activated, this warhead unleashes a devastating barrage of high-velocity fragments designed with meticulous engineering to obliterate the structural integrity of the target. What does such overwhelming destructive power mean for the future of air combat, particularly for pilot survivability and the cost of losing an advanced aircraft? The PL-15 employs two primary and highly effective detonation methods: direct contact and proximity. In the contact mode, the missile detonates instantly upon direct physical impact with the target, ensuring complete and irreversible destruction. In proximity mode, the warhead is ingeniously programmed to explode when the target enters its closest kill zone, even if there isn't a direct physical hit. This dual-mode detonation mechanism vastly enhances the PL-15's combat effectiveness and flexibility, making it particularly lethal against fast-moving or highly maneuverable adversaries that might otherwise evade a direct impact. Adding another layer to its sophisticated design, the PL-15 incorporates advanced stealth features into its physical structure, helping it evade detection by enemy radar systems during its flight path. This low observable characteristic potentially gives it a significant edge over its primary Western rival, the AIM-120 Advanced Medium-Range Air-to-Air Missile, AMRAAM, manufactured by Raytheon and currently a staple of the US military and its allies. How does this stealth-enabled missile fundamentally reshape the balance of power in beyond visual range engagements, forcing adversaries to rethink their counter-strategies? The PL-15's superior range is a point of particular concern for Western strategists. Its operational envelope significantly surpasses that of the AIM-120, which is generally considered effective only up to approximately 110 kilometers, depending on the variant. This disparity in range has reportedly prompted Lockheed Martin to undertake the urgent development of the AIM-260 Joint Advanced Tactical Missile, JATM, specifically designed to restore the US Air Force's crucial range advantage. Furthermore, the PL-15 is integrated with the very latest anti-jamming technology, making it highly resilient to electronic countermeasures, ECM, that might otherwise disrupt its guidance systems. In contrast, the older AIM-9X and earlier variants of the AIM-120 are considered more vulnerable to these sophisticated electronic warfare methods. The profound concern over the PL-15's capabilities was palpable when China first publicly acknowledged its testing on September 15, 2015. General Herbert Carlisle, then the head of the US Air Force's Air Combat Command, famously articulated this anxiety, stating, "Look at the weapons our adversaries are developing, like the PL-15 missile and its range. How do we counter this weapon, and what must we do to deal with that threat?" His words underscored the strategic shift. Is the West truly prepared for this new generation of threats? Or are they playing catch-up in a rapidly evolving technological arms race? Enjoying this deep dive? Tap subscribe so you don't miss what's next, as we uncover the cutting-edge secrets of modern air power. Beyond the formidable PL-15, the J-35 boasts a versatile array of weaponry that solidifies its air combat prowess. It is also armed with the short-range air-to-air missile PL-10, known colloquially as Thunder B-10. This particular missile is another testament to China's advanced defense research, developed by the Luoyang Electro-Optical Research Institute. The PL-10 is specifically engineered for close-range engagements, often referred to as dogfights, where agility and rapid response are paramount. Its technical specifications are remarkably similar to the AIM-9 Sidewinder, a staple missile carried by the F-35 and other Western fighters. However, the PL-10 reportedly features a longer range than its American counterpart, combined with exceptional flexibility and superior direct engagement capabilities. These characteristics transform it into a truly formidable dogfight assassin, giving the J-35 a significant edge in close-quarters aerial combat. How does this close-range killer complete the J-35's comprehensive air-to-air dominance, providing both beyond visual range and within visual range lethality? Equipped with a sophisticated infrared guidance system which tracks the heat signature of enemy aircraft and capable of reaching scorching speeds of Mach 2.5, the PL-10 can detect and destroy targets even in adverse weather conditions or amidst heavy electronic countermeasures. This passive guidance makes it particularly difficult to evade. Similar to the PL-15, it features a powerful fragmentation warhead designed to inflict substantial structural damage on aerial targets. But the J-35 isn't solely focused on air superiority, it is also a highly capable ground attack platform. For conducting strike missions against surface targets, it carries a versatile range of high-precision strike weapons. Most notably among these is the KD-20 ground attack cruise missile. This weapon, developed from the earlier CJ-10, is designed with a terrifying capability. It can carry both conventional and nuclear warheads, showcasing an immense destructive potential across a variety of strategic scenarios. What does the inclusion of such a dual-capability missile imply for regional stability and China's strategic deterrence posture? The KD-20 exhibits remarkable versatility, capable of fulfilling diverse mission profiles. It can destroy heavily fortified infrastructure, such as deeply buried bunkers and underground command centers, or neutralize critical installations like advanced radar systems and warships. Furthermore, it possesses the ability to completely wipe out entire strategic target areas, making it a weapon of mass effect. Its ingenious design allows it to fly extremely close to the terrain, often at treetop level, making it incredibly difficult to detect by even the most sophisticated radar and modern air defense systems. This terrain-following capability is crucial for survivability during long-range ingress. Combined with advanced guidance mechanisms, including a highly accurate inertial navigation system, GPS integration, and sophisticated terrain-matching algorithms, this weapon can maintain exceptionally high accuracy with a reported circular error, probable CEP, of only a few meters. This precision ensures effective and devastating strikes. With an impressive range of up to 2,000 kilometers, the KD-20 transforms the J-35 into an indispensable tool for striking deep within enemy territory without the need for the fighter to approach dangerous, heavily defended airspace. How does the ability to strike from such a vast distance revolutionize modern warfare, granting unprecedented standoff attack capabilities? What would you have done if you were designing this jet? Let me know in the comments. But the J-35's offensive prowess doesn't stop with missiles and cruise munitions. It also incorporates laser-guided bombs, specifically known as LS-6. These smart bombs represent a precision strike capability, allowing them to be released from high altitudes and then precisely track targets illuminated by lasers, either from the J-35 itself or from other friendly platforms, such as ground designators or unmanned aerial vehicles. This flexibility adds another layer of versatility to its ground attack role. In addition to these prominently featured weapons, the J-35 can also carry various anti-ship missiles and other conventional bombs, depending entirely on the specific mission requirements. This modularity ensures it can adapt to diverse operational needs. Complementing its offensive armaments, the J-35 is equipped with several modern defensive support systems, crucial for enhancing its survivability on the battlefield. These include advanced jamming systems designed to disrupt enemy radar and communications, and sophisticated decoy flares that can deflect heat-seeking missiles. What combination of active and passive defenses makes a fighter truly resilient in the face of multifaceted enemy threats? Moreover, the J-35 is equipped with an advanced, active, electronically scanned array AESA radar system. This state-of-the-art radar technology allows the aircraft to simultaneously detect and track multiple targets at exceptionally long distances, providing superior situational awareness. This powerful tool not only supports its air combat missions by enabling precise targeting and threat identification, but also assists in accurately identifying ground targets and guiding offensive weapons with extreme precision. The AESA radar is a cornerstone of its combat effectiveness. Beyond its inherent stealth features and potent firepower, the J-35 stands out remarkably for its lightweight construction. Its airframe and fuselage are meticulously crafted from a sophisticated combination of advanced materials, including aluminum-lithium alloys and various high-strength composite materials. These cutting-edge materials significantly improve the J-35's overall maneuverability, allowing for more dynamic and aggressive flight envelopes, and critically enhance its fuel efficiency. This improved fuel economy is a vital factor for long-range missions, particularly during extended patrols over vast maritime environments where refueling opportunities are scarce. How does cutting-edge materials, science, and lightweight engineering translate directly into a battlefield advantage, impacting everything from agility to operational reach? The fighter's aerodynamic design is another masterpiece of modern engineering. It features a distinctive delta wing configuration, which intrinsically provides substantial lift, thereby improving flight stability and enhancing overall performance, especially at the high speeds the J-35 is designed to achieve. The aircraft's control surfaces, including its vertical and horizontal stabilizers, are seamlessly integrated with an advanced fly-by-wire (FBW) electronic flight control system. This sophisticated digital system provides precise and rapid control inputs, allowing the J-35 to execute highly complex and technically demanding maneuvers that would be impossible with conventional mechanical controls. This increases its adaptability to diverse and rapidly evolving combat situations, making it particularly lethal in close-quarters dogfights. What kind of breathtaking aerial ballet and extreme combat maneuvers can such advanced control technology truly unleash, giving the pilot unparalleled command over the aircraft? The aircraft's engines are, without a doubt, a singularly critical factor in its overall performance, dictating everything from speed and altitude to combat power and operational range. In the early and formative stages of its development, J-35 prototypes were notably equipped with the RD-93 turbofan engine, which was manufactured by Klimov in Russia. This particular engine is an upgraded and refined version of the well-known Klimov RD-33, famously utilized on the MiG-29 fighter. The RD-93 was at the time highly regarded for its robust reliability and its ability to provide a powerful, consistent thrust, adequately meeting the J-35's initial demands for both air combat and ground attack missions. This reliance on Russian propulsion technology, however, immediately highlighted a strategic vulnerability for China. But how does relying on foreign-sourced engines, even high-performing ones, fundamentally limit a nation's long-term aerospace ambitions and geopolitical independence? This dependence on imported engines from Russia quickly became a recognized technical and strategic limitation for China's ambitious fighter development program. Beijing understood that true self-sufficiency and unconstrained military development required indigenous power plants. To overcome this critical hurdle, China has embarked on an intensive and heavily funded effort to develop its own domestic turbofan engines. Key examples include the WS-19 or WS-21 series, which are reportedly built upon the foundational technology of the WS-13 engine platform. These concerted efforts are not merely about producing an engine, they are aimed at achieving complete technological autonomy, thereby avoiding any future reliance on or vulnerability to foreign technology suppliers. The new domestic engines are designed not only to generate significantly more thrust than the older RD-93 with capabilities potentially exceeding 32,000 pounds of thrust, but also to substantially improve fuel efficiency. This enhanced fuel economy makes the J-35 far more effective for long-range missions, reducing its logistical footprint and extending its operational reach without constant refueling. Can China truly build its own advanced engine to rival the world's best, overcoming decades of technological gap? And what would such an achievement mean for its global standing? Despite these impressive advancements and the clear strategic imperative, the WS-19 and WS-21 engines are still undergoing rigorous refinement and continue to face some significant technical challenges. A notable and persistent issue often observed during test flights is the phenomenon of black smoke discharge from the engines. This isn't merely an aesthetic flaw, it carries serious tactical implications. Such a visible exhaust plume could significantly increase the J-35's detectability by enemy infrared tracking systems, which passively detect heat, or even, in certain conditions, by the naked eye during daylight operations. This remains a considerable vulnerability that needs urgent rectification to fully enhance the aircraft's stealth capabilities and overall operational effectiveness in a contested environment. Even if the J-35's engines aren't yet perfectly optimized, the aircraft compensates with a highly modern and integrated aerial refueling system. This capability significantly extends its operational range and combat endurance, allowing it to remain airborne for much longer periods. This is absolutely crucial for long-range missions, deep strike operations, or when conducting extended patrols over vast oceanic expanses where permanent land-based refueling bases are simply not available. How does a seemingly simple refueling port multiply a fighter's power and extend its strategic reach, turning a tactical necessity into a force multiplier? Furthermore, the J-35's landing system is not singularly designed but rather optimized for highly flexible operation on both conventional land-based runways and, crucially, on the pitching decks of aircraft carriers at sea. Specifically, the J-35 is equipped with a robust arrestor hook, an absolutely essential piece of equipment for safely landing on an aircraft carrier by catching the ship's arrestor wires. Its tail section is also engineered with extraordinary strength, designed to withstand the immense impact forces generated during carrier landings and the abrupt deceleration caused by engaging the arrestor gear. The aircraft's landing gear itself is constructed to absorb significant impact forces, ensuring safe and reliable landings on various runway types, even under challenging conditions. This versatility in landing capability underpins its role as a potential carrier-borne fighter. How does such meticulously engineered and versatile landing gear unlock entirely new tactical possibilities, transforming a land-based design into a naval asset? Beyond these practical advantages, Chinese engineers have also integrated highly advanced data link systems into the J-35. These high-speed data links are not just for basic communication. They allow the aircraft to seamlessly share critical tactical data and real-time intelligence with other friendly units, whether they are other J-35s, command and control aircraft, or ground-based assets. This networked capability provides all participating forces with a comprehensive and dynamically updated picture of the entire battlefield, fostering superior situational awareness. This interconnectedness not only dramatically enhances coordination and synergy among diverse forces, but also crucially assists both pilots in the cockpit and commanders in their decision centers in making rapid, accurate, and informed choices, especially during highly complex and rapidly evolving missions. Through these comprehensive capabilities, the J-35 emerges as not just an individual combat platform, but a fully integrated and effective component of a broader networked warfare ecosystem, poised to play a crucial role in modern military doctrines. Is this truly the multi-role warrior China claims it is, capable of both independent action and seamless integration into complex operations? After all this detailed analysis, let's put the J-35 squarely head-to-head with the F-35, the very rival China explicitly aims to surpass. The J-35 appears to hold certain distinct and potentially game-changing advantages. Its speed and service ceiling are initial striking points of superiority. The J-35 can reportedly achieve a blistering top speed of Mach 2, significantly outperforming the F-35's maximum of Mach 1.6. This difference is not trivial. It grants the Chinese fighter a crucial edge in rapidly approaching targets, executing its mission, and swiftly withdrawing, minimizing its exposure to enemy fire. Furthermore, the J-35's operational service ceiling is a remarkable 5,000 meters higher than that of the F-35. This significant difference in altitude capability largely stems from the two aircraft's distinct engine designs. The Chinese jet is a powerful twin-engine platform, while the F-35 is equipped with a single, albeit highly advanced engine. This twin-engine configuration provides greater thrust, allowing for higher altitudes and speeds. Does raw speed and altitude still define air superiority in the era of stealth, or are other factors now more critical in determining victory? Another significant point of pride for the J-35 in its rivalry with the F-35 is its extended attack range. This advantage is primarily conferred by its integration of the formidable PL-15 missile, a weapon system we've explored in detail. This long-range air-to-air missile allows the J-35 to engage and neutralize targets from a much greater, safer distance, operating from a formidable standoff position. This minimizes the risk of the J-35 being detected or engaged by enemy counterattacks, effectively dictating the terms of engagement on its own terms. From a broader economic perspective, the development and subsequent production costs of the J-35 are widely predicted to be significantly lower than those associated with the F-35. This cost-effectiveness is largely attributed to China's deliberate strategy of utilizing almost entirely domestically produced components and technologies. This economic advantage is crucial. It could potentially enable China to manufacture a substantially larger number of J-35 aircraft without incurring the astronomical costs associated with the F-35 program, all while projecting substantial air power across strategically important regions. Can cost-effectiveness, scaled across a larger fleet, truly translate into a decisive strategic advantage, even against a technologically superior but more expensive opponent? Furthermore, this deliberate reliance on domestic production grants China a critical degree of strategic autonomy. It frees them from any dependence on international partners or foreign suppliers for crucial aircraft components. This insular approach significantly mitigates potential political and commercial risks, such as embargoes, supply chain disruptions, or intellectual property disputes, which can severely hamper military readiness and expansion. In stark contrast, the F-35 program is heavily reliant on a complex web of international supply chains and a diverse array of allied nations. While this fosters international cooperation, it can occasionally lead to intricate issues concerning maintenance, component production, and logistical challenges impacting the overall readiness and availability of the F-35 fleet globally. Is the F-35's globalized supply chain its hidden Achilles heel, a potential vulnerability in an era of heightened geopolitical tensions? Despite the J-35's numerous modern and highly advanced features, promising a formidable new capability, it is crucial to acknowledge that it still harbors several significant weaknesses when compared directly to the battle-proven F-35. Firstly, the F-35 is equipped with arguably the most sophisticated and seamlessly integrated control and information systems ever fielded in a fighter jet. This includes a multifunctional active electronically scanned array, AESA, radar, cutting-edge optical and infrared sensor systems like the EOTS and DAS, and a revolutionary helmet-mounted display that projects all critical flight and combat information directly onto the pilot's visor. This comprehensive sensor fusion provides the pilot with unparalleled, rapid, and precise situational awareness, turning the F-35 into an information powerhouse. While the J-35 also possesses modern radar and electronic warfare systems, it has yet to demonstrate or even match the F-35's extraordinary level of integration, sensor fusion, and overall operational effectiveness. Is raw capability in individual systems truly enough, or does seamless, intuitive integration define the ultimate superiority of a modern fighter? In terms of operational readiness and long-term maintenance, while the F-35 certainly commands a higher unit cost and greater operational expenses, each aircraft benefits from a globally established, highly sophisticated, and meticulously refined maintenance and repair process. This comprehensive support system minimizes downtime, ensuring that the F-35 fleet maintains a high level of combat readiness and maximizes its operational efficiency. This robust system is underpinned by highly specialized teams of technicians, state-of-the-art diagnostic tools, and advanced support software that allows engineers to continuously monitor the aircraft's health and proactively detect technical issues before they escalate. The J-35, conversely, remains very much in its development and refinement stages. Its logistical and maintenance infrastructure is nascent, still being built from the ground up. Therefore, it cannot yet guarantee the same rigorous level of reliability, efficiency, or rapid turnaround times as the F-35. Can China truly build a world-class, battle-ready maintenance infrastructure from scratch, a task that has taken decades for established military powers? Multi-role capability is another critical domain where the F-35 demonstrates clear superiority over its emerging Chinese rival. The F-35 family is designed for incredible versatility, exemplified by the vertical takeoff and landing (VTOL) capabilities of the F-35B variant, allowing it to operate from amphibious assault ships, and the robust carrier launch and recovery systems of the F-35C, designed for traditional aircraft carriers. This inherent adaptability means the F-35 can seamlessly perform a wide array of missions encompassing air combat, precision ground attack, and defensive interception, all within a single airframe. While the J-35 theoretically boasts a flexible and advanced weapon system that allows it to meet diverse combat requirements, from destroying enemy aircraft to striking strategic ground targets, this theoretical capability has yet to be fully proven in the crucible of real-world operations or large-scale exercises. Is theoretical capability and impressive specifications truly enough? Or does extensive real-world combat experience and proven versatility reign supreme in determining a fighter's true value? This leads us to what is arguably the J-35's most significant and overarching weakness, its profound lack of real-world operational and combat experience. The F-35, in stark contrast, has been extensively deployed and utilized by numerous military forces across the globe, including the powerful US Air Force, Navy, and Marine Corps, as well as a growing coalition of allied nations. This global deployment has translated into thousands upon thousands of accumulated flight hours, providing engineers and strategists with invaluable practical experience, crucial feedback, and real-world data. This wealth of information has allowed for continuous improvements, refinements and bug fixes, iteratively perfecting the F-35's design and performance. The J-35, however, remains squarely in its development and testing phases. It simply lacks extensive combat experience to definitively prove its effectiveness, especially regarding its low observable stealth capabilities, which is perhaps the single most crucial yet hardest to verify aspect of a fifth-generation fighter. Can any fighter truly prove its ultimate mettle, its resilience, and its groundbreaking capabilities without facing the unforgiving crucible of real combat against a determined adversary? The answer remains a profound and pivotal unknown. In a world increasingly defined by geopolitical tensions, particularly across the Indo-Pacific, the emergence of the J-35 is far more than just another military development. It's a profound statement, a clear assertion of China's burgeoning defense industry and an unmistakable symbol of Beijing's strategic ambitions. This new stealth fighter sharpens the already fierce competition between China and the United States, especially in the critical domains of air superiority and global influence. The skies above us are not merely empty space, they are a canvas for national power and a silent battleground for the future. While the J-35 showcases an impressive array of modern and advanced features, promising capabilities that could rival the best, a fundamental question lingers. Is it truly formidable enough to challenge the F-35, that established icon of American air power? The answer remains elusive, shrouded in the unknown, as the J-35 has yet to officially enter active combat. We've seen its design, understood its theoretical potential, and examined its arsenal, but the true test of any war machine lies not on the drawing board or in controlled test flights, but in the unforgiving reality of conflict. Can potential ever truly eclipse proven performance? Yet one undeniable truth emerges from this unfolding narrative. In this relentless arms race, in this struggle for international influence, China is ceaselessly innovating. They are pushing boundaries, proving themselves to be a formidable adversary, one that demands the world's attention more than ever before. The J-35 isn't just a plane, it's a testament to a nation's resolve, a metallic embodiment of its aspirations. It forces us to reconsider what we thought we knew about the balance of power, sparking new debates and anxieties. As the global stage continues to shift, what other technological surprises await us? And how will they redraw the lines of conflict and cooperation? The future of air superiority